All right, folks, welcome back from Christmas break. Hope all of you had a good, restful break and that you're ready to get back into it. Need to let you know that the Algebra 1 SOL has been scheduled for January 22nd. And from what I've been told, that is unlikely to change. So January 22nd will be your SOL. So here is the plan. I think at this point, what I need to tell you is there will be things on that SOL that we did not get to. So you are going to see things on there that you do not know how to do. That's a product of the fact that we've only gone to school 4 days a week. And, virtually we just can't get as much done as we could had we been in class. So I don't want you to stress out about that. Just recognize that there will be things on there you don't know how to do. Be okay with that. And on those problems, you're just going to have to take your best guess. And, maybe you get lucky. So what we are going to do is, starting today, we are going to review all of the things that we have done and make sure you know how to do those and do them well. And if you get those questions right, if you get the things right that we have done, you should be fine. You should have no trouble passing. I am being told, and I will get confirmation on this, but I'm being told that instead of a 400, you will only have to score a 350. So that takes some of the pressure off as well. So please, over the course of the next couple of weeks, 2.5 weeks, work hard on the review that is assigned. Probably I will be setting up some Zoom meetings where you can pop in and ask questions if you need to. But, whatever I can do to help you get ready, if you need Zoom calls to do that, please be sure and let me know. I'm here for you, and I'll do what I can. So, with that said, we are going to review a couple of things today that we've done. And you'll practice some problems, and we'll go from there. All right, so the first thing we are going to review today is evaluating algebraic expressions. So evaluating algebraic expressions. This is one of the first things that we did way back in August and early September. Problems that you saw then looked like this. It would say something like evaluate 2x plus 3y if x equals 5 and y equals 4. So evaluate 2x plus 3y if you know that x is equal to 5 and y is equal to 4. So you all know what has to be done here. You know that we have to plug in 5 for the x, and then we have to plug in 4 for the y, and then we have to work this out. Now, when you do your SOL test, here is the big thing that I want to encourage you to do. On one of these problems, I want you to start by looking at the two variables in the problem, which are x and y. All right? If x or y is being raised to a power, then I want you to put that x or y in a set of parentheses. If the x or the y is being multiplied by something, I want you to put that x or y in parentheses. So look right here. This x has a 2 in front of it, which means we're doing 2 times x. So when you see this 2 times x, I want you to write it on your paper like this. 2 times x. Use parentheses to show that multiplication. All right, then we have plus 3y. This y is being multiplied by 3, so again, I want you to write it like this. So 2 times x plus 3 times y. Use parentheses to show those multiplications. All right, now we're going to plug in. So 2 times x is going to become 2 times 5, plus 3 times y is going to become 3 times 4. And then we're going to work this out. Now to work it out by hand, we can go back and use GEMDAS. So does the problem have any grouping symbols in it? Well, it has parentheses, but there's nothing to do inside of the parentheses, so no. Does this problem have exponents in it? It doesn't. Does it have multiplying or dividing? It has multiplying, so we're going to work left to right with that. So we're going to do 2 times 5 is 10, plus 3 times 4 is 12. We're going to do both of those multiplications. And then, of course, we add or subtract. 10 plus 12 is going to be 22. And 22 is the answer. Now, I want to remind you that you can also use your Desmos calculator to do this. So if it were me, I would write it like this on my paper first, on my scratch paper, with the parentheses around the x and the y, and then plug those numbers in. And then what you would do, and I want you to try this, then what you would do is you would go to your Desmos calculator and type that right there that I just highlighted. You would type that in, and you would type it in exactly the way that I have it on the board. And it should give you that same answer. But type it in exactly as you see it using parentheses and all. But I'm telling you, using the parentheses is going to be the key to getting these right. So take the time to look at your variables and write it using parentheses if necessary. Okay, let's try another one of these. All right, so let's do x squared plus 2x plus y. X squared plus 2x plus y, so let's evaluate that. If x is equal to negative 5, y is equal to negative 3. Now, here's what I want you to do. I want you to take the time, first of all, to look at this and see if you need to add any parentheses, because parentheses are the key. So right here, I see that this x is being raised to the second power. One of the things that I've talked to you about and that I need for you to remember now is that when a variable is being raised to a power, that variable needs to go in parentheses. So when you see x squared, I want you to think of it as x in parentheses squared. Any variable that's squared needs to be wrapped in parentheses. All right, now I'm going to move over and I'm going to look here at this x. This x is being multiplied by 2. So I'm going to need parentheses to show that. So I'm going to write this as plus 2 parentheses x. So those parentheses will clarify that that is multiplying. And then moving on to the next part of my problem, I see plus y. No parentheses are necessary there because that's just a single variable. I can't mess that up. So I'm adding parentheses around this x because of the exponent. I'm adding parentheses around this x because of the multiplying that's happening right here. And I'm not adding parentheses around that y because they're not necessary. Nothing is happening to him. All right, so now let's fill in the numbers. This x is going to become a negative 5. This x is going to become a negative 5. And this y is going to become a negative 3. All right, now, if I go through GEMDAS, does this have grouping symbols? Well, the parentheses just have negative 5. These just have negative 5, so no. Do I have exponents? Yes, I do. So I've got to do negative 5 squared. Now remember, when you type this into the Desmos calculator, you have to type it in with the parentheses. If you don't, you will get the wrong answer. Negative 5 squared means negative 5 times negative 5, which is a positive 25. positive 25. Use those parentheses when you type into the calculator. All right, then we have plus 2 times negative 5 plus a negative 3. Now we look for multiplying or dividing. We have multiplying right here in the middle, so we're going to do that. So that's going to be 25 plus 2 times negative 5 is negative 10 plus negative 3. And then last we go through and we add and subtract left to right. So 25 plus negative 10 is 15, and 15 plus a negative 3 is 12. Now again here, because that Desmos calculator is going to be built into your test, you could start here and write this with the parentheses that are necessary. And then when you fill those numbers in, then you could take what I'm highlighting right now and type that into your Desmos calculator as is, with parentheses and all. And that should give you this same answer of 12. So that would be a way to kind of check your work and make sure that you have it right. So I would encourage you to do that. Always write this step where you add the parentheses that are necessary, then fill in the numbers, and then type this phrase with the parentheses and all directly into that Desmos calculator and get your answer. So I would encourage you, that Desmos calculator will be built into the test, and I would encourage you to use it for everything that you can. All right, let's do one more. Let's do xy plus y squared minus 7. So let's evaluate that. If x is 2 and y is negative 8. So let's evaluate if x is 2 and y is negative 8. All right, so let's take a look first. You've got the variable x and you've got the variable y, and they're right beside each other. So do I need parentheses around either one of those? And the answer is yes, because when I see xy, I know that means x times y. So I want to make sure that I don't mess that up. I want to make sure that I keep that multiplication intact. All right, now, moving on into the problem, I see plus y squared. So this y is being squared. So because he's being raised to a power, I know he's going to need some parentheses to help him out with that. And then I see my minus 7, so I just bring that down. So this x and this y need parentheses because they're being multiplied. This y needs parentheses because he has an exponent. So now let's put the numbers in. The x gets replaced with a 2. The y with a negative 8, the y with a negative 8, and now I've got this thing ready to go. So I go through GEMDAS, or let me say this first. You could, at this point, you've written it with the parentheses that were needed, you've filled in the numbers, you could just take this expression right here and type it into the Desmos calculator just like you see it, and get that answer, or you could work it out using GEMDAS. So does this have any grouping symbols? Parentheses are here, but there's nothing to do inside of them, so no grouping symbols. Is there an exponent? Yes, right here. So we're going to do negative 8 squared first. So this is going to be 2 times negative 8 plus what? Negative 8 squared means negative 8 times negative 8. That is a positive 64 minus 7. Do I have any multiplying or dividing? Right here, 2 times negative 8 is a negative 16 plus 64 minus 7. Adding and subtracting, work left to right. So we're going to do negative 16 plus 64. That is going to be 48 minus 7. And then 48 minus 7 is 41. 41. Now, I've taken the time there to do the work. But remember, you could just write this first on your paper, adding the parentheses, then fill in the numbers, and then just type this into your Desmos calculator and not fool with all of that showing of the steps. Generally, on an SOL test, there will be 1 or 2 of these. You need them. You need them right. So please listen to what I'm telling you about adding those parentheses. And if you're not crystal clear on when you're adding or when to add parentheses and why, then let me know, because that is super important. All right, so you'll have some questions today to review on this. Now, the other thing that we are going to review today is solving multi-step equations. Now, when we solved multi-step equations, you all were very, very good at this. Remember, there were 5 steps. Step 1 was to distribute, if necessary. Step 2 was to combine like terms. That were on the same side. Step 3 was to cancel the smallest variable. And remember, we did that by adding or subtracting. Step 4 was to undo adding or subtracting. And then step 5 was to undo multiplying or dividing. Remember that to undo something or to cancel it, you do the opposite. And remember that what we do to one side of an equation, we have to do to the other to keep it balanced. So, let's get into a few examples here. All right, for our first one, let's do -3 times x minus 8 minus x plus 5 is equal to 23. Now, you all will remember that when we did these, I had you start by drawing a line through the equal sign to show the two sides of the equation. All right, now first, we're going to distribute if necessary, and it is necessary. So right here, we're going to take -3 and distribute it to everything in these parentheses. So we're going to do -3 times x, which is -3x, and then -3 times -8, which is a positive 24. Remember to watch your signs. On your second set of parentheses, notice there's a minus and no number here. Remember that means there's a 1 there. So we'll do -1 times x is a -1x. And -1 times positive 5 is a -5. So here's what our equation will look like after we have distributed. The next step is to combine like terms that are on the same side. So we're going to look at side 1 and see if there are any like terms, and there are. We can combine a -3x with a -1x. Those are like terms. And we can also combine a positive 24 with a -5. So if I do -3 minus 1, I get -4x. And then if I do 24 minus 5, I get positive 19. So I get -4x plus 19 is equal to 23. All right. So we have distributed and we have combined like terms. Now we're up to step 3, which is to cancel the smallest variable. When you look at the problem, there is only one variable, -4x. So if there's only one variable, you do not need to cancel the smallest. There isn't a smallest if there's only one. So step 3 does not need to be done. Step 4 is to undo adding or subtracting. So you all remember, this is where I told you to cover up the variable. So cover up that -4x. You see plus 19, undo it. So you're going to subtract 19 on both sides. Those cancel. That gives you negative 4x is equal to 23 minus 19, which should be 4. And then our very last step is to undo multiplying or dividing. We see negative 4 times x. So we are going to do the opposite and divide by negative 4. And we get x is equal to a negative 1. So that equation is solved. Okay, here's another. Let's say we have 9 times x minus 3 plus 3x is equal to 7x plus 43. All right, line through the equal sign. And let's work the steps. Step 1, distribute if necessary. And it is. We're going to distribute 9 to everything in here. So 9 times x is 9x. 9 times negative 3 is negative 27. Then we have plus 3x is equal to 7x plus 43. So step 1, distribute if necessary, is done. Now we move on to step 2, combine like terms that are on the same side. When I look at side 1 of this equation, I do see a couple of like terms, 9x and positive 3x, so I'm going to combine those. 9x plus 3x is 12x minus 27. And then when I look over here, I don't see any like terms, so I'm just going to bring that down, 7x plus 43. So I distributed, combine like terms, and now I'm up to step 3. Cancel the smallest variable. Now you'll notice this time there are two variables, a 12x and a 7x. So we need to cancel the smallest. The smallest is the 7. So you will subtract 7x, do the opposite to cancel that out since he's positive. So you're going to do minus 7x on each side. 12x minus 7x gives us 5x minus 27 is equal to 43. So we have done steps 1, 2, and 3. Step 4 is to undo adding or subtracting, so I would cover up that 5x. When I do, I see minus 27, so I would add 27 to undo that. That gives me 5x is equal to 70. And then we'll divide both sides by 5 and get x is equal to 14. So you got to know those 5 steps. You all were good at them way back when, so let's review them and make sure that we are good. Now I do need to remind you here that there are some special cases. So we did see those. Here's one of them. 3 times 2x plus 2 minus 3x is equal to 6 plus 3x. So we'll do this problem. And then here is the other special case. 3x minus 13 is equal to 7 times x plus 2 minus 4 times x minus 7. I have a lot of room for that one, do I? All right, so we'll come over here first and we'll draw our line through the equal sign. And we'll go through the steps. Do we need to distribute? Yes. 3 times 2x is 6x. 3 times 2 is 6, so 6x plus 6 minus 3x is equal to 6 plus 3x. Can we combine like terms that are on the same side? I see that. I can combine 6x with negative 3x. On the left side, 6x minus 3x makes this 3x plus 6 is equal to 6 plus 3x. Cancel the smallest variable. Here's what makes this one special. You see two variables, 3x and 3x, but they are the same. There is no smallest. So I got to cancel 3x. So subtract 3x, subtract 3x. So what ends up happening is you don't just cancel the smallest, you cancel them both. That's what makes this special, is that you cancel both variables. And look what you're left with. You're left with 6 equals 6. Now, 6 equals 6 is true. That's true. So remember that this equation has infinite solutions. All right, and let's look at this last one. Okay. Do we need to distribute? Yes. We have 3x minus 13 is equal to 7 times x, which is 7x. 7 times positive 2 is positive 14. Negative 4 times x is negative 4x. And negative 4 times negative 7 is a positive 28. Watch your signs there. Okay, can we combine like terms on the same side? Not on this side, but over here we can combine 7x with negative 4x. And positive 14 with positive 28. So, we're going to have 3x minus 13 over here. 7x minus 4x is 3x. 14 plus 28 makes 42. Now, cancel the smallest variable. Notice again the variables are the same, so we are canceling 3x, both of them. So you have negative 13 is equal to 42, which is false. So remember that means this one was a no solution. So the special cases are infinite solutions and no solutions. And you will recognize those because the two variables will be the same, which means that when you cancel one, you automatically cancel the other. So you don't just cancel the smallest, you cancel them all. Now, before we leave these equations behind, I want to remind you that we also learned how to do this on our Desmos calculator. So let me see if I can show you that. All right, so here is Desmos. If you're going to do these on your calculator, on your Desmos calculator, remember, if they don't use X, you need to use X when you type it in the calculator. So you have to use the variable X no matter what they use. So we would type this problem in exactly the way we see it. So we would do negative 3, parentheses, x minus 8, close parentheses, minus 1, parentheses, x plus 5, close parentheses, equals 23. And what you'll notice is this red line over here on the graph, and right there on that little dot, we click, and you'll notice you get negative 1 as your x value. X equals negative 1 was the solution. Here's the other one we did. So I'll show you it real quick. You would do 9, parentheses, x minus 3, plus 3x equals 7x plus 43. Now, notice over here I'm not seeing a line, but notice my x value was 14. So remember, you can zoom out until you can see your line, and when I click right there I get 14 as my x value. So the Desmos calculator can also be used to solve these multi-step equations. Please make sure you try the problems that are assigned for today, because we need to know where you stand on this. January 22nd will be here before we know it. It's 2 weeks from Friday. So let me know if you have questions. Let me know if there are things I can help with. I will be sending out an invitation next week for a Zoom meeting, and I hope to see you all there.